Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Okay, well today we're going to be doing a little bit of ESD testing. This kind of came about because I was seeing the ADC crash occasionally, and we didn't start seeing this until we moved to the metal faceplates. And of course the external Wi-Fi. So I have that set up as well, and I'll give you a close-up of the test bed here in a second, how I've got everything set up. But yeah, so to do ESD testing, you need, of course, everything set up. This is the chamber probe. This is a meat probe. Of course, a Muxall Pro BBQ Controller. It is powered by AC. Whoops. And as you can see, it's just holding on by threads. No, but it is AC powered. I have an earth ground right here, which is what holds the earth ground on the barbecues will grounds the faceplate and the temperature probe. I'm sorry, the chamber probe. The meat probe though is basically not grounded. I know it's got a metal sheath on it, and it comes up into the controller, but this thing is not actually tied to ground, and I can show you that, or you can just believe me. Oh, the last piece of test equipment we need is this chair. You're probably wondering what the chair is for. Well, the chair is my static electricity generator. I do not have carpet out in the lab, and rubbing the probe on my hair didn't work. I actually tried that. So, but I found if I sit up and down on this chair enough, I can generate enough static electricity to give the controller a pretty good zap. So, all right, I'm going to tighten this up. I'll do that off camera real quick. I'll be right back. Okay, so I went ahead and tightened the chamber probe up. Everything else should be okay. I haven't checked to see if the Wi-Fi is connected. It really doesn't matter. I'm sure it is. We'll go ahead. I'll do a test so you can see how I do this. And I'll give it a zap. We'll see what happens. And then I'll do a close-up where you guys can watch the controller close up. All right? So, let's do this. All right, I'm gonna put my glasses on here. All right, so here we go. Okay. I found going in circles helps. So don't ask me why. Okay, ready? I should be all charged up. I can feel my pants kind of clinging. We'll do the chamber probe first. Yeah, wasn't too much. I felt a little bit, but this thing's fairly static tolerant because this thing is tied directly to ground. The meat probe's not so much. We'll do that one here in a second. But let me get a good charge going here. There we go. Okay, ready? Did you hear that? I brought my external mic out here. We'll do a close up. Yeah, see, it didn't affect it any. You'll know when it affects it. It will beep when it resets the ADC. I put a fix in there for that. And all right, well, we'll just go ahead and do the meat probe. That's a lot easier to do. All right. Yeah, this is good exercise at CSD testing. Okay, I should have a charge on myself. Here we go. Oh. All right, do that again. All right. Oh, there it goes. See? think I was talking when it beeped. Alright. Yeah, it recovered. That's good. So yeah, that's it. Now I'm going to go ahead and try to zap the Wi-Fi antenna, and then we'll move in for some close-ups, and I'll turn on this external mic so you can hear it. All right. Good charge. All right. Oh, nothing. I actually haven't tried the antenna. It's kind of coated in plastic. I might not be able to get enough potential. I was trying to hit the connector back here. All right. Well, let's just do a close-up. We'll do more testing with a close-up so you can hear it and see what I'm zapping. I think you've seen me twirl around on the chair enough. Well, we're zoomed in here now, and just kind of show you the close-up. Here's the chamber probe up here, or chamber temperature probe. Here's a meat probe, Wi-Fi antenna. I have my little mic down here. That's what I'm using now. So if it sounds kind of funny, it's because the mic's here instead of over on my head. And oh yeah, so a couple things. Yeah, this is earth ground up here. This is tied to earth ground, just plugged into the wall here in the lab. And I also have a 1 meg bleeder resistor off of the power supply coming off the high voltage board. This is to drain any coupled AC coupled buildup of electricity base, any voltage buildup on the PCB. I think that's what was causing the problems for folks that were using it without touching it. Zapping it definitely is an easy way to reproduce it. ESD can be thousands of volts, and hardly any current, but thousands of volts. And yeah, so you can zap pretty much anything pretty good if it's not protected. The ADC seems to be very sensitive to the ESD. It doesn't seem to damage it. I have protection resistors in there. If you've seen some of my designs videos, you'll know what I'm talking about. Okay, so yeah, let's go ahead. We'll let me generate some more AC here, or some more current real quick. Hold on. I've twirled around on the chair a few times. We'll go ahead and zap the meat probe again. Did you hear it? Well, it never fails when you're trying to... Okay, hold on. Okay. Well, let's try the button panel. Oh, there it goes, yeah. I didn't really hear it zap it, but it was enough. Okay. So, well, anyway, and if you're wondering about the meat probe, you know, how it's zapping it, so, oh, there you go, check that out. I must have had enough residual in me to zap that again. Huh. Anyway, it's got to be like arcing over, right? So there's no connection from the outer sheathing to the meat probe, you know, the outside metal part of the meat probe. So it's got to be arcing across in those to the wires inside, right? There's just not enough dielectric material in between there to you know, stop it from arcing across, and it's getting on the inputs of the ADC, and it's causing it grief. Yeah, that's pretty interesting. As you can see, it recovers okay. So, I mean, I don't know how much you could zap it. I've zapped it pretty good. In fact, we'll try it one more time, see if we can get a nice big pop out of it. And I'll do the meat probe. So hold on. Okay, you ready? Jared, Jared, it didn't even bother it. Huh. Oh, well, maybe it did bother it. It just took it a while to zero out. Well, that's kind of interesting. Look at that. Huh. Very interesting. Well, as you can see, it recovers. So, what's the conclusion from this? You're probably asking yourself, right? Well, yeah, I give it a rating of a, it's okay, right? It's going to be fine. The ADC it has buffered inputs. It has its own, so, and it also has resistors to protect input current, input current protection. It's got input current protection, and then the ESD spikes. I could probably look at putting some clamping diodes in that for to protect against the ESD spikes. But then that just adds another layer of of something else I could go if you zap something and your diode goes south on you, then you've got problems there too, right? I mean, this thing works. It's fussing with the ADC. The ADC is protected, so it's recovering okay. It might actually be something else. When I respin this board into the version 4 model, I'll look at that, and I'll also contact LTC / Analog Devices and see what they say about it. But I've already talked to a couple of engineers over at Analog Devices, and I'm using their reference design, and they've looked at it, and they seem to think it looks pretty good. So they were even asking about the input protection, but I said, yeah, that'd be a good idea on a barbecue, just in case, because that thing is, this thing, people are holding it around, drinking beer, and there's no telling where they're going to stick that thing. So, I wanted to make sure the controller was protected. And this is another thing. This is not an ESD thing. This is for if potential starts building up between the controller and the ground on the barbecue. This will allow everything to kind of balance out, and it's got like a 1 megohm resistor in between there, just to kind of bleed the current off, bleed the potential off without, basically, we don't want to feed a bunch of noise off the earth ground into the controller. That would be really bad. But with a 1 megohm resistor, that should just be enough to bleed off any current that might get AC coupled into the controller. So there you have it. I hope you found that interesting. I know I found it interesting. I'm going to give it some more testing, zap it some more, and see if I can create a failure mode it doesn't recover from. But so far it doesn't. It seems to be doing pretty good. So, all right. I'll see you later. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.